Hello and welcome. So we have here a string of terms together in an expression. We have quite a few radicals here we need to combine. Now there's a few things to keep in mind here. First off, in order to add or subtract any radicals, we have to have the same index and we must have the same radicand, right? And I'll just mention it straight off the bat on this one, right? The first two are a must qualification. This third one is going to be helpful simply because we have variables in the mix here, so I do want to mention it as well, right? Is that they have to algebraically be like terms. And what I mean by that is kind of like if I have an x plus 4, can those combine together to make it like 4x or 5x? No, right? In order to add anything in algebra, right, anything combining with an x must have that same x to that same power. So we have the variable b here, and one's to the fifth, another one's to a tenth. This one doesn't even have a b at all on the outside. Not only do we need to have radicals with like terms in the radical sense of the idea with the same index and same radicand, we also need to have algebraically with our variables the same variable to same power to combine them easily as well, right? It's not impossible, but it would require some fancy writing there. So we'll usually just keep them separated if they don't have that third qualification. Okay, so let's just get right into it. So right now, nothing has the same radicand. We can already see that all the insides are different, so that's a problem, right? Something else to kind of notice here is that index is that checkmark area. There's nothing written, which means we get to assume that's a 2, right? That tells me I'm looking for pairs as I'm simplifying. All right, so let me kind of take that out so we have a little extra room to write with. All right, so right now, nothing looks like it's the same radicand until we simplify, right? Once we simplify, that's kind of like the great equalizer where we could really see whether something's the same radicand or not. So let's get all of that simplifying done, and then we can add potentially at the end. Okay, so let's just dig right into this. The first thing I see is a 360. I recognize the number 36. I know 6 can go into 36. That should be 6 times 60. All right, and then that will be 6 times 10, which is 2 and 5. Now the 6's can break down to 2 and 3, but I'm looking for, remember, pairs of the same number. And having 2 6's is a pair of the same number. I don't have to break them down. Even if I did break them down to be 2 and 3, 2 and 3, I'd literally bring out a pair of 2's and a pair of 3's. And what is 2 times 3? 2 times 3 gives us, hey, look, 6. So it's not going to change how we do the problem. And then reminder, whatever we do bring out multiplies to what's already there. So our 18, if I'm bringing a 6 out, I'll have 18 times 6, right? And then times b to the 10th. That's already there. Now we have a b to the third inside of our radical here. That's like saying b times b times b. Well, we could for a pair with 2 out of the 3, so that means a b will come out there. And then what will remain is the numbers we couldn't form the pair with, right? So 2 and 5, those multiply back together to give us 10. And then one of the b's could not be used, so that stays behind as well. All right, so that will give us 18 times 6, which is 108, b to the 11th, because 10 b's times 1 more is 11 b's in total. All right, next one. I'm just going to write the 5 from the beginning, because either way we're going to have it there. Now 90 is 9 times 10, which is 2 and 5. 9 is 3 and 3. Are there any pairs? Yeah, a 3. So let's bring that out. And we can't bring out the 2 and 5. There's no pair, so that'll leave behind a 10. Now, the variables are a little harder on this one. There are 23 b's in there. All right, now I'm not going to write out 23 b's and start circling pairs. That's a little ridiculous. How many times does 2 fit into 23? well, at least 11 times, right? Because 2 times 11 is 22, which means I can form 11 pairs of the B's, and that will use up 22 of the 23 in there. So we have B to the 11th, and there will be 1 left. Because of my 23 B's, 22 of them get used to create pairs, and then the very last one doesn't have a pair, so it has to stay behind. All right, there we go. So my next term will be, oops, I forgot that radical in the first one. 5 times 3, which is 15, b to the 11th, square root 10b, which we can already see is going to be a like term, right? Same radical, same index, and same algebraic like term, right? A b to the 11th in front. So promising. Let's look at our last one here. All right, 250 I can already see as a 25 and 10. 25 is 5 and 5, 2 and 5 from the 10, right? So the 2 and 5 from the 10 aren't going to do anything, but I can pull a 5 out from my 25. So the 2, b to the 5th, is chilling right there. I can pull a 5 out. All right, and then that will leave behind a 10 number-wise. Now we have a b to the 13th chilling right there. How many pairs can I make with 13 b's? Well, I can form 6 pairs, right? 6 times 2 would be 12, so that would use 12 of the 13 b's, so there would be 1 b left inside. So that means my next one will be 2 times 5, so plus 10. 5 b's times 6 b's is 11 b's, square root 10b. So, at the beginning, it didn't look like any of these would combine, and in the end, we can see that all of these are going to combine, right? They have the same radicands, they have the same index, and they have the same variables to the same exponents. All of these add together. So all we do is just add those coefficients, right? 108 plus 15 plus 10. And there we go, we get 133. Reminder, when you add, powers do not change on variables, and radicals do not change when you add either. Literally, it's only the number in front that will change. So 133, b to the 11th, square root 10b. And because our variables are positive, we're not worrying about any kind of absolute values or anything. All right. Whew. That's crazy as it gets. That one was a little long. It's a little hardy on the simplification. If you take your time, you're going to be totally fine. Thanks for watching.